Let's say I want to build a bridge. I clearly have a lot to think about, particularly if it's over a big drop. But a key decision is going to be materials. What do I construct my bridge from? Well, I need to think about its weight, strength, stiffness, elastic limit, fracture toughness, and much more. I also need to bear in mind how my new bridge is going to be used and the environmental conditions it must work under. The same principles apply whether I'm selecting materials for a new bridge, or a prosthetic limb, or a racing car axle, whatever. I have to choose the right materials. Let me tell you about Ashby plots. This is ASU. The Ashby plot derives its name from the influential materials scientist Professor Michael Ashby, who revolutionized our approach to material selection. Why do we even need an approach? Well, the challenge with selecting a particular material for a specific product or a specific part of a product is that this selection is rarely, if ever, made on the basis of a single aspect of that material. For example, how does one select the right material for a single-use container for water? It needs to cost as little as possible, since we're selling water here and not the container itself. It must be easily recyclable. The material must also be easy to manufacture into bottle-like shapes and resist all the transport and handling loads that it will see once it's filled with water. We'd also like it to be transparent so the customer can see what's inside and know that they're drinking clean water. And by the way, it should be very lightweight so it can be easily carried around. Now, what material meets all these requirements? I know what you're thinking. Isn't there a handbook or something where you can go to page 743, find the lowest cost material, and then cross-reference it against the strengths of materials listed on pages 328 to 397? Then you turn to page 1745 and look for the appendix that lists all transparent materials before looking back at your notes and realizing that you skipped page 239, which lists all the materials that can be easily formed. You get my point, I'm sure. Handbooks are great, but we need something more comprehensive, something that brings it all together in one place, and something that is more visual than tables with numbers. We did not evolve to look at tables with numbers. We evolved to see the fruit among the leaves. Enter the Ashby plot. The Ashby plot is really a scatter plot of data points, but the clever bit lies in the context of material selection in that it contains two or more properties, like strength and weight, for example, on the same graph. Not impressed? How about this? It also contains this information for several materials. In fact, it contains it for several types and subtypes of materials. You could have metals rubbing cheeks with plastics, and ceramics and composites sharing tricks. You could have foams and honeycombs, bone and sinew. You could even decide how many to have, or how few, with shapes like balloons and with different colors too. Oh, the materials you'll compare. Sorry, I got carried away there. Today, you can find Ashby plots packaged into software for designers to use. These packages enable the designer to pick the requirements of most importance and compare all the options. Designers can then not just select the optimum material, but they can also import it into their design validation. They can conduct computer simulations on designs with different materials and ensure they pick the ones that survive the loads and environmental conditions imposed on them. By the way, if the Ashby plot sounds too much like a murder mystery involving the stabbing of a 1,000-page hardbound materials handbook in the basement stacks of a university library, you can also use the much drier but equally accurate Ashby chart. And if that sounds like something you'd use in navigating your way around said university library, well, I'm out of ideas really. Just select one and move on. So, for that bridge you are designing, the choice of materials must match the usage, the environmental conditions, the intended lifespan, as well as the budget you have. Ashby plots will help fill some of these gaps, and so they are crucial to your design process. They give design engineers amazing insights into how their future structures are going to behave. And that also means you don't have to carry that handbook around any longer. This was ASU. Thanks for watching.